Now for the error, we just apply our formula. So x minus x node over t average, that is y. Error of y over y is equal error of x minus x node over x minus x node plus error of t over t. So we write it as follows. First of all, we said we don't know the error, so we give it so many digits. Error is equal y, which is this one, multiply, we open the brackets, and then inside the brackets we have delta x over x plus delta t over t. Now we put the value. Delta error of x minus x node is half divided by x minus x node, this value, and then error of t is this one divided by t. We don't know how many digits, so we show many digits in order to judge error is one significant digit, and then we drag it. So it's clear that here we need to see one digit, one significant digit, and the rest we need to show one digit to make it one significant figure, and then we just copy what we have. So now we are ready to do the linest function. A linest function will give us the slope, error of slope, intercept, error of intercept, r square, and error of y. So we choose a cell, equal, and then, sorry, I don't need, I will just choose this cell. Any cell will work, linest. So this is the function, I double click on it. Known y values. So we will draw it, draw the graph x minus x node over t. So that's my y values, comma, my x value, my x-axis values, comma, and then I write true, comma, true. So this is my slope. This is my slope. To show the other three values, the other 6 values, so I choose 6 cells, and then I put the pointer here, click on it, and then I press Control with Shift, and then Enter. Control with Shift, keep pressing them. While pressing them, I'll press Enter, and I need the cursor to be here at the top. Okay, so those are the 6 values. I am interested in them. If you write those values alone in your lab report, you will take 0. You will not take any mark for the linest for 2 reasons. First of all, I don't know what's the first value, what's the second value, whatsoever, just a bunch of numbers. That's one. 2, so they don't have titles, they don't have units, and you need to apply error is one significant digit, and number has to match the error in accuracy. So R square, we don't change. We put it as is. So equal this value That's r square. We don't, as many digits as there is, it's okay. The closer it's to 1, that means your data is linear. Your data is linear and follow the same equation of a straight line. Slope error is 1.17. Error must be one significant digit, so I write 1. I write 1. Number has to match the error in terms of accuracy. So here I see ones, so accuracy must not be less than ones. So I write 28. And the units, I prepared it before, and the units will change based on the experiment, of course. Intercept error 1.54. Error must be one significant digit. It will be 2. Number has to match the error, so it is minus 8. The error is ones. The error is ones, means 1 or 2 or 3. that we call أحاد, يعني أحاد. Ones are أحاد. فبالتالي النمبر must be accurate, most accurate is أحاد. ما بنقدرش نحط 0.4 لأنه 0.4 1 على 10. Number cannot be more accurate than the error. And finally, the error bar, or when I draw my graph, the error bar in the y-axis is this number, which is 0.4. Which is 0.4. Can I change this, move it, put it here? Yes, I can. So now the last thing is we need to do our graph. So our graph, this is in the y-axis, and this is in the x-axis. And this is our graph. So I will tell you a very fast shortcut. I go here, quick layout, and I choose this. Here I have the function, it's fit, linear fit. I have titles, and I can just do the graph very fast. So here it is, can I copy this, put it on the title? Let me see. Copy. Node versus time versus t. X node. Let me just okay, and here I write t second, and here I'll try to copy this. Maybe I'm lucky. My computer is very slow today. Yeah, I copied it. I just try to make it a little bit more beautiful. I'll just here I need just to add the units, centimeter per second. Now, if you submit a graph like this, I mean, all this area is empty, you will lose heavily. You will lose heavily. طب what I shall do, this point should be here in this corner. I need to spread my data all over the graph. I need to spread my data all over the graph. You see here it's close to 1, so I will just change my starting point in the x-axis. It starts from 0, I'll make it start from 1. And here it's close to 20. I make it start at 20. Now it's kind of acceptable. And now I need to add my error bars. So many ways to do that. I will show you one way. If you have another way, it's okay. You go here, you go for error bars, and then you choose standard error. You choose standard error, and then we change it manually. We click on the x-axis error, double click, and we choose fixed value, and we choose the largest error of t, which is 0.06. The largest error of t, 0.06, and I add it manually. That's 0.06. And for the y-axis, it's already error, y error, it's 0.4. I choose the y-axis error and fixed value, and I put 0.4. That's all what you need. I think if you have other question, you can ask me during the lab. Thank you so much, and I hope all of you will have a full mark in the lab.